Hello everyone, dear students. In this lecture, let us learn about glass. After this session, you will be able to know the definition of glass, what is glassy state and its properties, classification of glass, the raw materials required for the manufacturing of glass, and the process of manufacturing of glass. Firstly, we can define glass in two ways. Chemically, it is a fused mixture of non-crystalline silicates of alkali and alkaline earth metals. Physically, we can define glass as a hard, rigid, transparent, amorphous, supercooled, brittle, solid solution having no definite melting point. Glass is called supercooled liquid because it is an amorphous solid. Amorphous solids have the tendency to flow but slowly. Due to this fluidity property, glass is called as supercooled liquid. I think now you are thinking what is amorphous, right? Let me clarify you. See, this is the molecular structure of quartz and quartz glass. Although both have same chemical composition, that is SiO2, quartz is a crystalline solid and glass is amorphous. Crystalline means the particles are arranged in a definite pattern. Here there is a long range order. See here, there is a definite pattern, repetitive pattern is there in the crystalline solid. But in case of amorphous solids like glass, the particles are not in definite pattern and there is no long range order. So this molecular structure of glass is responsible for all the properties of glass. Now let us see what is glassy state. Glassy state is a state of matter that is amorphous or disordered like a liquid in structure but acquires the mechanical properties of a solid because of gradual increase in its viscosity. So the transition from the molten state to the glassy state is reversible. You can consider this glassy state as an intermediate state between solid state and the liquid state. The glassy state has a number of important and specific features. Let us see what are those. The most important property of the glassy state is the capability of continuous transformation from the molten state and vice versa. The process of solidification does not involve the formation of a new phase, but this transition from liquid phase to solid phase and vice versa produces a continuous change in physico-chemical properties. The next feature is it is isotropic in nature, which means the magnitude of some of the physical properties of glass like refractive index, coefficient of thermal expansion, electrical and thermal conductivities is same in all directions. This is due to the amorphous structure of glass, as I had already told you. But remember, the crystalline substances are anisotropic in nature. The next one is the properties of the material depends on its composition. Then a glass possesses higher internal energy than a crystalline substance of the same composition. Because of this, it is less stable. Then it has no definite melting point. When glass is heated, it does not melt at a fixed temperature. On heating glass, the glass gets gradually softened and can be molded into any desired shape. This property of glass has made it a very useful material. Now coming to the classification. There are different ways of classifying glasses. In your syllabus, you have classification of glass based on its major constituent, that is silica. On this basis, the glass is classified as silicate glasses and non-silicate glasses. Silicate glasses are the glasses whose main chemical constituent is silica, that is silicon dioxide. These are the most familiar and historically the oldest type of glass, and these are brittle in nature. So you can consider the fused quartz, that is a glass made from chemically pure silica. It is a silicate glass. Other example for this type of glass are soda lime glass, borosilicate glass, lead glass, aluminosilicate glass, etc. Coming to the non-silicate glasses. So these are silica free glasses. These are formed by many inorganic and organic materials including amorphous metals, aluminates, phosphates, borates, chalcogenides, nitrates, plastics, acrylic, etc. These often have poor glass forming tendencies, but these have desirable properties for applications in modern communication technology. Chalcogenide glass. See here, chalcogenides. Chalcogenide glass is a glass containing one or more chalcogens such as sulfur, selenium, tellurium. So these form the basis of rewritable CD and DVD, solid state memory technology. It is now known that glasses can be formed from almost any material, either organic or inorganic, if cooled rapidly by avoiding crystallization. One can get glass from any material. Now let us see what are the raw materials required for the manufacture of glass. The first and foremost important raw material required is silica, that is SiO2. Then soda ash, that is sodium carbonate, limestone, that is calcium carbonate, and then cullet, Cullet means broken glass pieces. So these broken glass pieces facilitates the melting of raw materials as they are heated. Most cullet is the waste obtained from glass forming operations, and some are obtained from recycled glass products. So these are the main raw materials used. Other materials used depend on the type of glass being made. Now let us see the steps involved in the manufacture of glass. So this involves 5 steps. The first one, it is formation of batch material. The second step is melting of those raw materials at high temperature. Then processing of that molten mass, that is shaping of the molten material. Then annealing of that formed glass articles. The final step is finishing. Now let us discuss each step in detail. The first step, that is formation of batch material. So the raw materials such as quartz or sand, soda ash, limestone are crushed and finely powdered. The required quantities of different ingredients are separately weighed and then mixed uniformly. This mixture of powdered raw materials such as sand, soda ash, limestone is called batch material. Then the second step, melting. The batch materials are loaded into one end of a large rectangular tank built of refractory blocks. That is, refractory blocks means the bricks, refractory bricks are the one which can withstand high temperature. So here we call this as tank furnace. It is mixed with cullet. So you already know cullet reduces the melting point of the batch material. This tank furnace is generally fired on the regenerative principle of heat economy. What is this regenerative principle of heat economy means? The burnt gases from the tank furnace are made to pass through one set of chambers packed with regenerators which can absorb heat energy. When these regenerators are heated to maximum temperature, the fuel and air are passed through them so that the fuel and air get heated up. The direction of flow of burnt gases and fuel air mixture are changed alternately. In this way, heat of burnt waste gases is utilized in heating up the incoming fuel gas and air previous to burning. Thereby, heat economy is achieved. So this is the regenerative principle of heat economy. So the furnace is heated to about 1600 Kelvin. At this temperature, the materials melt and react to form molten glass. These reactions will take place, leading to the formation of glass. Heating is continued till the glass melt is free from gas bubbles. Undecomposed raw materials and impurities form a scum called glass gall, which is skimmed off. The clear liquid is now allowed to cool after adding the necessary decolorizers or coloring agents. It is cooled so that it will have a proper viscosity for shaping. The third step, that is shaping. The molten glass is run into molds and automatic machines turn them into desired shapes such as rods, tubes, sheets, wires, bottles, etc. The fourth step is annealing. So this is a very important step. The process of gradual cooling of glass, which is used to reduce strain in the glass, is known as annealing. Since glass is an insulator, rapid cooling will cool the surface of the glass more quickly than the internal portion, causing an internal strain. Such glass articles becomes brittle and fragile. If cooled very slowly, it devitrifies and becomes opaque. Therefore, the glass articles should be cooled neither very slowly nor very quickly. For this purpose, the glass articles are made to pass through several hot chambers called lahar. These lahars are long tunnel-like furnace which is very hot at the mouth end and very cold at the tail end, so that the articles are cooled gradually during their passage through the tunnel. This process of gradual cooling of glass, which is used to reduce strain, is known as annealing. Thus, annealing makes the glass articles more durable and resistant to shock and change in temperature. Then, the final step is finishing. It is usually carried out by cleaning, washing, grinding, polishing, cutting, sandblasting, enameling, grading and gauging. Washing and cleaning are common to all kinds of articles. The other methods of finishing are adopted according to the requirements. So this is all about the manufacturing and processing of glass. Thank you.